Welcome to part 10 of this Dave on Data tutorial series, a Python crash course. The topic of this video is for loops and while loops. Loops are how you ensure your Python code is executed multiple times as part of some process. For example, running code for each customer in a dataset. Not surprisingly, Python loops are a fundamental skill for anybody that wants to use Python for anything. As always, please follow along with this video by typing the code that I type. Don't hesitate to pause or rewind the video if needed, because you learn Python by writing Python. So I'm back in my control flow Jupyter Notebook, which I created in the last lesson video, and we're going to add a subsection here for loops. For loops are the base construct that you use for controlling the flow of your Python code when you want code to be executed more than once. So that's a bit abstract. As usual, seeing some code makes everything much more clear. So what I'm going to do here is I'm going to create something known as a range object. And these are very handy in Python. So I'm going to call it my range, and the class for creating a range object, the blueprint, is called range, not surprisingly. And what I can do is provide it a start and stop value. And just so you can see what's going on behind the scenes, we can say print my range and then print my range casted or transformed as a list. And if I run this code, what you can see here is that when I just print my range, it says, look, Dave, my range is a range object, ranging from 0 to 5. And once again, notice what's going on here when I actually transform it to a list. The actual values are 0, 1, 2, 3, 4. And this aligns with what we saw in the slicing video earlier in the series, where this range object starts at 0 and goes up to, but does not include 5. So 0 through 4, exactly what we would expect given that Python counts from 0. So I've got a range object. I can use this to control the flow of execution of some Python code using a for loop. So use the range with a for loop. Oh, let's capitalize that. And we'll go ahead and say for. Notice how it's green. That tells me that it is a Python keyword. And then what we can say is, all right, I have a range of values stored in my underscore range. Okay, and I want to use that. I want to say, look, I want to execute some code for every piece of data that's in my range. Not surprisingly, I use the word in. And then I can say, I know I've got a collection of values, so I'll say, hey, for every value in my range, go ahead and do some code. Now notice we're using a colon here, just like we did with if statements. This tells Python, hey, a block of code is coming. And as we learned with if statements, you have to indent code to recognize, so that Python recognizes it as a code block to be included in your for loop. So let's do something interesting. We could say, hey, let's use an F string here. I don't care about value. Now notice what we got going on here. We're using an F string, which we learned about quite a while ago, which is just a formatted string. And notice that what I'm doing here is using the value here. And I'm saying, look, for every time there's a new value for value, because remember, my range includes the values 0, 1, 2, 3, 4. So print this out for the value of 0, print this out for the value of 1, so on and so forth up to 4. And if I run this code, you get exactly what we would expect. This particular for loop is executed a total of 5 times because there are 5 values in my range. And for every unique value inside of my range, this line of code is executed. Now, this is obviously a very contrived example and quite silly, but we have to crawl before we walk and walk before we run. And this is most definitely crawling with a for loop. But here's the thing. We can do any arbitrarily complicated thing inside of our for loops. And this is going to be an arbitrarily complicated contrived example. So bear with me. So I can use an if statement. And I can say, hey, is the value currently equivalent to 2? If it is, go ahead and do something. And say print, let's use an F string again. I care about value. And then we can also put an else in here, as we learned. And now see what's going on. Oh, I don't like that indentation. Let's fix that. So here we have the same basic structure. The for loop code is going to be executed a total of 5 times. Once for the value of 0, 1, 2, 3, 4. And then what we've put inside it is some logic that says, look, if the value is currently equal to 2, then print this line, otherwise print this line. And if I run this code, this is what we get. I don't care about 0, I don't care about 1, I care about 2. I don't care about 3. I don't care about 4. So this goes to show the basic idea behind for loops. It allows you to control the flow of your execution of your code to allow it to run multiple times, and the code that you run multiple times can be arbitrarily complex using all the building blocks you've learned so far. Okay, moving on. You can use essentially lists in your for loops. You don't have to use a range object. Those are commonly used, but you don't have to. You can actually use any arbitrary list to control the execution of a for loop. Use a list with a for loop. And I'm going to create an object called string list, which is of type list, right? Square brackets. And then I'm going to use the string 1, 2, 3, 4. That's enough. No, actually, let's do 5. Why not? Let's keep it equivalent to what we saw before in terms of the number of iterations of the for loop. Okay, so I've got a list here of 5 string values, and I can do something like this. I could say for each string in my string list object, go ahead and print the string. And if I run this, 1, 2, 3, 4, 5, exactly what you would expect. So you can put any arbitrary object inside of a list. You know that already from a previous lesson, which means that you can use a for loop to iterate over or process code multiple times for any arbitrary object contained in a list. So these could be strings, they could be integers, they could be entire tables of data. Anything that you can think of, any type of object can be put in a list, and then you can iterate over them. Now we can mix and match some of the stuff that we've learned, which is really, really cool. This is something you actually do, by the way. What I'm about ready to demonstrate here, this pattern, is something you actually do in analytics code. So we're going to build a list using a for loop. And we saw this before in a previous lesson. We can create an empty list like this. So I have a list object that contains nothing. It's a totally valid concept. Just like if I have a jar in my house, I can have a jar with nothing in it. The jar is still a jar. So what I can do here is I'm going to reuse my range object just for grinsies. So we've seen this before, but let's do something cool. If the value is 2, skip it. If value is equivalent to 2, run this line of code here, and I'm going to use a special word called continue. This is a very, very useful construct inside of for loops. This continue essentially says, look, as soon as you hit continue here, go back up and process the next thing. Okay, I'm going to run this code and check it out. Notice that what's in my list is only 0, 1, 3, and 4 because I've skipped over the value of 2. Because once a value becomes 2 here as it's going through each value in my range, this continue says, look, don't care about anything else in the remainder of the code block here. Just pop back up and go to the next one. So we get 0 appended, 1 appended, 2 gets skipped, 3, 4. And notice what we've got going on here. Notice how important this is. This is at the heart of writing Python code, is making sure that you have the right indentation, making sure you have the right white space to understand what's going on. So all of this code right here that's highlighted is considered a single for loop code block. If you don't like this, you could also do this code here like this, remove the white space, and works just fine. I tend to like a little bit more white space in my code, so there you go. All right, next up, we're going to build a list with a for loop again. So I'm replacing my list with a new empty list again. I'm essentially overwriting it. For value in my range, I'm using the range object again. If the value is 4, stop. Okay, so if value is equivalent to 4, break. Break is a keyword that stops the for loop from executing, from iterating, from going through all of the values in my underscore range. Okay, so if I run this, not surprisingly, I get 0, 1, 2, 3. Because what ends up happening is we're going through all this code, right? 5 times ostensibly because there are 5 values in my range. And what we can see here is that we break when the value equals 4, which happens to be the last value. And when I break, it just exits out of the loop essentially. And so this line of code never gets called. So we get 0, 1, 2, 3, 4. So notice what's going on here. We have ways to control the flow of the execution of our for loops itself using combinations of if else, continue, and break. Okay, I'm going to go ahead and create some more cells here. And now we're going to be talking about the next kind of loop that's commonly used in Python, which is known as a while loop. So a while loop is fundamentally different than a for loop. A for loop executes a block of code once for each element of some sort of collection. So for example, if I have a list of string values, as we just saw, it will process a for loop code block for every string value in the list. A while loop works in that it runs the block of code in the while loop as long as some sort of condition has the value of true. So this actually makes while loops kind of dangerous in many, many ways. And we're going to explore some of these right now. So the danger of while loops. So let's say I have a variable called a, not a good name, and I set it equal to the value of true. I can use a while loop and say, hey, while a is true, do some code. And I'm going to go ahead and print danger exclamation point. Now, if I run this code, it will run forever. I will have to actually manually stop the code cell from executing because what it's going to do is just print danger forever. And you can see here, whoa, it doesn't like that at all. So I'm going to click the stop button here to stop the code cell. And what you can see here is danger, 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 right? So this is the danger of while loops. A is always true. There's nothing to change it from true to false. So this particular code block here inside the while loop runs forever. So when you use a while loop, you have to make sure that you have an exit condition that's in the code somewhere that trips the while loop to stop. Move on. Let's talk about actually making a while loop that works the way you intend. A better example. So we can still have a equals 0. Sorry, not still. We'll make a equal to 0, excuse me. And then we'll create a while loop that says, hey, while a is less than 10. Now notice that the exit condition is already present in the code. I'm indicating at least my intent that this while loop will not run forever. So I can go ahead and print a. But here's the thing, this alone is not enough to make the code actually exit out of the while loop. I need to increment the value of a or change the value of a so that eventually it's no longer less than 10. Because if I run this code right now, I'll get zeros printed forever because the value of a never changes. It's always less than 10, so the code just runs forever. So we can do something like this, a equals a plus 1, or if you prefer, you can eliminate the white space here. Totally up to you. Now here's the thing, notice what's going on. A comes into the while loop with a value of 0. Is 0 less than 10? Yes, it is. Execute the code block, print a, and then increment a. Make a now the value of what it was before plus 1. So 0 plus 1 is 1. I go back up to the top of the while loop. A is currently 1. Is that less than 10? Yep. Print it. Increment it. Come back. Circle around, circle around, circle around till eventually A becomes 10. And then at this point, this is no longer true. This Boolean condition is no longer true, and the while loop will stop. So if I run this, notice I get 0 through 9, which is what we would expect. Okay, but notice that two things are important to make while loops work. You need to define the exit condition, and then somehow in your code, you need to make sure that eventually the exit condition is reached. Otherwise, it'll just keep running forever. Now, you might think this is ridiculously simple to do, but actually, it's pretty insidious. It's actually quite easy to mess this up. So here is another dangerous example. A equals 0 once again, while a is less than 10. Now, notice what I'm doing here. You can also use continues and breaks, just like you did in for loops. You can use them inside of while loops, and they do exactly the same thing. Now, ostensibly, this all looks pretty good, right? I've got my exit condition defined, a less than or equal to 10, and I also have code to change the value of a, so that eventually it should get to 10, except for I've got this little thing right here. And let's see what happens when I run this code. Notice that it's running forever, but it's not printing stuff out. So I'm just going to go ahead and stop this. So let's talk about what's happening here. So what ends up happening is that as long as a is less than 7, everything is awesome. So we check it and we print it and we increment it so we get 0, 1, 2, 3, 4, 5, 6. As soon as we hit 7, continue goes back up to here. And a is 7, a is 7, a is 7, a is 7. And this just goes on and on and on and on forever. It never stops. And that's why we get only 0 through 6 printed. But notice that if I do this again, I get the asterisk, which tells me that this code cell is running and it's just not going to stop until I actually interrupt it by clicking the stop button. So all that to say, you have to be really, really super careful with while loops. In general, if you can get away with using a for loop, that is a better idea than using a while loop because while loops are prone to do funky stuff if you're not really super careful. Moving on. So another better example, a equals 0 once again, while a is less than 10. Now I'm using numbers here, but any logical condition, of course, applies. If a is not equal to 7, print a equals a plus 1. Because notice what's going on here. If I scroll back up to the previous cell, maybe my intent was, for whatever reason, I wanted to print out all the numbers from 0 to 9 except for 7. Except for 7. And I wrote my code like this, and I goofed up because it doesn't work the way I intended. But this code will actually print out all of the values 0 through 9 except for 7. So if I run this, you can see here, sure enough, 0, 1, 2, 3, 4, 5, 6, no 7, 8, and 9. Okay, and let's talk about what's going on here. We can see here that A starts at 0, and this check says, look, as long as it's not equal to 7, print the value, but keep incrementing. So I'm going to eventually hit my exit condition because I've defined it, and I've made my code increase the value of A. And then I can say, for each iteration of the while loop, I check the individual value of A and only print the things that I want. And that's how we can do something like that. But notice the subtlety here. You really got to be thinking about this a lot when you're working with while loops. To finish up our coverage of while loops, check this out. We're going to be breaking out of a while loop. So we've seen continue, which works conceptually exactly the same in both for loops and while loops. Not surprisingly, so does break. Now notice this gives us a different variation on the same theme here. What's going to happen is this code block is going to print up every value 0 up to and including 6 and then stop. Because notice what we got here is we're doing a break, not a continue. Because break actually stops the entire while loop process, whereas continue says just go back up here, go back up here, go back up here. Break says nope, exit out, we're done with this code. There you have it. The absolute basics of for loops and while loops. This is everything that you need to know to get started. Don't forget to save your work if you're following along by clicking on the save button. Also, don't forget to shut down the notebook and the Jupyter Notebook server if you want to free up the resources on your computer. When you're ready to take your Python skills to the next level with analytics and data science, be sure to check out my free crash courses. As you can see here at the time of this recording, I have 4 crash courses available for you, totally free. Here's what you get when you register. You can watch the video whenever it's convenient for you. You get a PDF of all the slides, you get all the code and data, and you get additional resources for continuing your learning. And I've got 4 right now: logistic regression, decision trees and tuning decision trees. These should really be watched together, by the way, just so you know. And then lastly, one on cluster analysis using k-means. So these are available for you when you're ready. There will be links to all of these crash courses in the description below the video and also in the pinned comment. So next up in this series, we're going to talk about list comprehensions. That is a super important topic in Python. You use list comprehensions all the time when you use Python for analytics and data science. So stay tuned for that. When that video is ready, I'll put a tile right up here on the screen and you can just click on it and you can watch the next video in the series. If you're liking this video, please go ahead and smash the like button. And if you know somebody that could benefit from this series, why don't you recommend it to them? And until next time, I wish you very happy data sleuthing.